Your eye is essentially the structure that captures photons or light rays from the surrounding environment. So let's take a little bit of a look at what that looks like. Okay, so if we draw the eye, and we have to remember some structures from the anatomy of the eye, right? We have the outer part, which makes up the fibrous tunic, which includes the cornea, which is going to be this section here, and then the sclera here. Okay. Then we have sort of the iris. I'm going to draw this in cross section. Or sorry, sagittal section, I mean. Okay. And then you have the lens. And I'm going to draw the lens in yellow, I think. Like so. Okay, now let's imagine that we have an object out here. It's just going to be a circle. And then we give that object a light source. Right? Light is going to come down. It's going to hit the object. Some of the light rays are going to be absorbed, but then some of them are going to be reflected off. And some of them will be reflected off, and they will come towards the eye. And the first thing that they are going to hit is that cornea. So they're going to come this way, and they're going to hit the cornea. This one will go this way, and that'll hit the cornea. The cornea, the first job of it is to refract or bend the light. So it's going to bend the light. And then the light, those photons, those light rays are going to hit the lens, and the lens is going to bend the light a second time. Then it's going to travel through the lens, and it's going to travel out the posterior, the backside of the lens, where it's going to get bent again. Okay, then these rays, photons, are going to come back, and they're going to converge on the retina. So where these light rays converge, this is known as the focal point. Okay, that is known as the focal point, and you want the focal point to be on your retina. Right? So let's take a look at what might happen if we do this again in red. And I'm going to start here in the lens, where it gets bent, like so, and it comes back, and my focal point is here. Well, there's nothing stopping those photons, those light rays. One's going to come back, and it's going to hit the retina there, and this one's going to come all the way back, and it's going to hit the retina here. Well, what that's going to do is it's going to tell your brain that this object is down here, and then the one that's hitting the retina here is going to say, well, the object's up here. Right? So this is essentially telling our brain that this object is in two different locations. So if we have that on small scale, imagine we have our structure and we say one of it says that the boundary is there, then the other says that the boundary is, right here. So we have offsetting boundaries a little bit, and this is what's going to lead to blurred vision. So the same can be true if the light rays aren't refracted enough and they converge at a point behind the retina, back here. Okay, so this one would say that it hits there. This one says that it hits here, right? But it does the same thing, is it that it tells the retina or hits the retina at different points, which tells our brain that this object is in two different locations. So if it hits in front of the retina, that's what we call myopia or nearsightedness. And if it hits behind the retina, this is what we call hyperopia or farsightedness. So nearsightedness, farsightedness, right? And so that's what leads to the different visual conditions that you might see. So if we take and we look at this sort of again, draw my eye, sort of a bad drawing here, do some erasing. Draw my cornea out here. I'll draw my lens in yellow again, like so. What happens if I take this object and I move it really, really, really close to my eye? Well, notice that when light gets reflected off of that object, the angle at which it hits the eye is if the object were here versus if the object is, let's put it way out here. Now look at the angle that we're at, okay? So if we move the object far out here, the angle is less, right, than if it were close. So if we look at this, right, and we want the light rays to converge at a single point, if the angle of the light rays is like this, right, think about how much we need to bend them to get them parallel, and then bend them to get them to converge on the retina, versus if the object is way out here and the light rays come in this degree, like this. Now how much do we need to bend them? And then bend them again to get them to converge. So notice that in the red condition versus the pink condition, right, this condition here, that we need to bend the light rays more. So which do you think is a better condition for bending the light rays more? Do you want the lens to look more bulbous in nature, or do you want it to look more elongated in nature? Which one of these is going to provide a greater refractory angle? This one, right? The more bulbous one. So when it's close, when an object is close, you want that lens to be more bulbous in nature. When it's far away, you want it to be more elongated in nature. Okay? But notice, let's go ahead and draw this inside of the eye. Circle drawing is not doing great today. And let's go ahead and put a lens in there. And I'm going to make it super elongated, like this. Say the object's far apart, far away. We'll do object 1 is like this. Okay, condition 1. All right, and then if we take that object and we move it closer, right, we said that our lens would change to a more bulbous shape, like this. So we'll call this condition 2. Okay, but we also have this structure that gives us the color of the eye, the iris, right, which is connected sort of like so. Like this. Okay, so when that lens changes shape, notice that the iris doesn't come all the way up to the lens. So this light ray, let's make it red, can squeak by, go through the pupil, which is the gap in the space in the iris, and it will go all the way through, and it won't get refracted at all, and it'll hit the retina over here. That's not a good condition, right? So what needs to happen is that when the eye and the lens adjust for things moving closer, and that lens adapts a more bulbous shape, the iris needs to constrict, and that pupil needs to constrict. So you can actually practice this on yourself in a mirror, or practice this with a partner. If you take an object, get them to focus on it far away from their face, and then move that object closer to their face, as they do so, and their lens adjusts shape so that you can get the greater refractory angle, their pupil will constrict as well, because that iris is responsible for blocking any sort of errant light rays from passing through without getting refracted by that lens. Okay? So that's how light rays are going to reach the retina.